Okay, just to make sure we understand the terminology here, a circle is all the points in the plane that are equal distance. And that distance is called the radius from a given point, which is called the center. It's important that you realize that it's all the points in a plane, because if we just said all the points that are an equal distance from the center, then we'd be talking about in all directions. And what shape would that become? A sphere. Okay? So it's important that we understand we're talking about just in a plane here. I think I forgot to save this after I made all my changes. And then looking at the circle, the blue line is the diameter. Diameter is all the way across the circle, passing through the center. The two red lines are radii. Radii is plural for radius, and so there's two of them. The central angle, we're talking about this angle right here. Central angle, not sure I have the definition here, but the central angle has its vertex at the center of the circle. Okay? So central angle has a vertex at the center of the circle. Had you written down the definition for that? There it is. Central angle is an angle whose vertex is at the center of the circle. And then an arc, or as part of a circle, okay? And I think we have definition of an arc here, don't we? No? So an arc, just to make sure we understand, is the part of the circle that's intercepted, is the word we use. It's intercepted by the radii, or chords, or whatever. It's being cut off by these segments. And so this is the arc. Okay? There's our arc. All right. Congruent circles have congruent radii. The diameter, we just said, his endpoints are on the circle and it passes through the center. Minor arc measures less than 180 degrees. Minor arc measures less than 180 degrees. And what I'm getting at here is this is how you label it. This is how you label a minor arc. The endpoints of the arc, okay, are the two letters you use. And if it's a minor arc, you only use two letters. Okay? If it's a major arc, has measure more than 180 degrees, then you use three letters. And the two on the outside have to be the endpoints. Okay? So A and C are the endpoints of this arc, and B is another point on the arc. B is another point on the arc. So if we go back up to our picture and I said, okay, this is A, and here's B, and here's C. Okay? So arc ABC would be this arc here. That would be arc ABC. That would be a major arc, okay, because it's more than 180 degrees. Whoops. I'm sorry. I wasn't looking closely. Now that is arc ABC. It doesn't start down here at the red, it starts right there. Okay? Any questions on what a major arc is? How to label? How about a minor arc? Okay, let's move on then. A semicircle is an arc that measures 180 degrees. So we're talking half the circle. So its endpoints of the semicircle, the endpoints of a semicircle would also be the endpoints of a diameter. Okay? Go back up and look for a second. Arc, if I labeled this D, so arc AD is a semicircle. Its endpoints are also the endpoints of the diameter AD. Now, I don't need three letters there because it doesn't matter which way I go. The arc is still half the arc. Okay? But it doesn't hurt. If you want to put 3 in, go ahead and put 3 in. All right. Adjacent arcs share a common endpoint and don't overlap. So adjacent here, arc BD and arc DC are adjacent. They share the endpoint D. They don't overlap each other. Okay? One that might overlap that's not adjacent, if I put some more letters here, let's call this E. If we say arc AE and arc AC, they both share A, but AC totally overlaps AE. Okay? Totally overlaps arc AE. All right. The angle, I'm sorry, you've done before angle addition and segment addition, and now we're talking about arc addition. And so simply saying if they're adjacent arcs, so they're not overlapping, they share a common endpoint, we can add those two arcs together to get the bigger arc. Okay? So in this picture, we're saying arc AB, which is here, plus arc BC, BC is here, okay, is equal to arc ABC all the way around, from A to C, passing through B. Now also, I could name this, and that's what I'm saying here, I can name this arc, let me draw it outside. I can name it arc ABC, I could also name it arc AEC, because it doesn't matter what point I choose that's on that arc, as long as it's on that arc that I'm looking at. And the endpoints have to be A and C. Okay? So there's more than one way of labeling that arc ABC. Any questions on it? All right, let's move on. Circumference, the distance around the circle. A couple formulas for circumference here. A couple examples. We'll get to that next one in a moment. All right, I'll pause while you copy. So in the first picture here, 5 inches represents the what of the circle? The radius. Well, we gave you 2 formulas, and the reality is they mean exactly the same thing. The exception is one of them has radius in it and one of them has diameter in it. So it's probably easiest if they give me the radius to use the formula with radius in it. But Jared might say, no, I don't want to do that. I want to use the other one. I'm just going to take my radius and do what to it to get the diameter? Multiply it by 2. Well, that's what's happening here. So that's okay. If Jared wants to do that separately and then throw it into that other formula, there's nothing wrong with that. All right? But if we use the radius one, we're going to say 2 pi times the radius, which is 5, and 2 times 5 is 10. And if they say find the exact value, that's how you have to leave the answer. Let me put the unit on the end, inches. It's not area, it's length. Circumference means the distance around, so it's just a length. So it's not square inches, it's just inches. If they say to round, then we'll plug that in our calculator and we'll round it off. If they say give the exact value or leave it in terms of pi, they might say leave it in terms of pi, then this is your answer. This is the exact, this is the exact value, or in terms of pi answer, however you want to say it. They both mean the same thing. If they say round to the 10th, then we take that number, plug it in our calculator, we get 31.4. Again, if you don't have one of these calculators and they're saying round to the 10th place, and you just say 3.14 times whatever, sometimes you'll have an error. Okay? I'm not going to say all the time. I'm not going to say most of the time or half the time or whatever. It might only happen once in a great while, but sometimes you'll have a rounding error. So my recommendation is if you just have a real simple-minded calculator in front of you, then throw in 4 digits here if they say to round. So you'll be way less likely to have a rounding error. I guarantee rounding to the tenths, you'll never have a rounding error if you use those 4 digits. But if you use just 3.14 occasionally, you can have a rounding error. All right? So on the next one, they give me 6 meters, which represents what? The diameter. And probably it'd be easier to use the formula for diameter. And pi times the diameter, which is 6. Again, in terms of pi, it would be 6 pi centimeters. And if they say to round, then I'd plug that in my calculator. Help me out here. What am I going to get? 19 point what? Is it 19? 18.84. 18.84. So if I round to the tenths place, I'll say 18.8. Okay? If they say, oops, I forgot to finish putting my unit up here. If they say round, or leave it in terms of pi, or the exact value, I'd use 6 pi. If they say round to the tenths place, I get 18.8 centimeters, and the M didn't look very good. Okay? 18.8 centimeters. All right. Measure an arc. The symbol M in front of the arc, AB, means the measure of the arc. So the measure of the central angle that created the arc AB. So the measure of an arc is the same as the measure of the central angle that created that arc. Then we have a formula for arc length here. I'll let you copy that down, then we'll talk about them. Okay, again, the measure of an arc is always equal to the measure of the central angle that created that arc. So this angle, AOB, has a measure of 120 degrees. That angle intercepts the the circle at A and B, and so that's creating this arc AB. So the measure of arc AB is going to equal the measure of this central angle. So in this case, it's 120 degrees. Measure of an arc is different than the length of an arc. The measure of an arc is very simple. It's always whatever the measure of the angle is that created that arc, the central angle that created it. Now the length of the arc is a little more involved. There's no great way to label this, so what I'm trying to say here in this part of the picture is that the measure of whatever the arc is, I don't know what it is. It's hard to put a variable in that place. So I just wrote the word arc in there small. Okay? So I'm saying the arc length is equal to the measure of the arc divided by 360 times C. What's C stand for, you think? Circumference. So what we're saying is this fraction here, the measure of the arc over 360 is telling me how much of the circle I'm talking about. And then C is the entire circle. So if I knew this radius here was 6 inches, and I want to find the length of arc AB, okay? Let's just go down here and use this example. And so arc AB is 100 degrees. So I'm going to say the measure of arc AB then is going to be 100 degrees divided by 360 times by the circumference. But we haven't found the circumference yet, so let's do that right here. I know many of you are copying this down ferociously. Jackson, you can multitask. How would I find the circumference of this? Times the circumference of the whole circle.
Oh yeah, 6 times pi. Or 12.
12 times pi?
Yeah.
So what he's saying is all the way across would be 12. And one formula, diameter is, one formula says diameter times pi. So he's saying 12 times pi. Okay? I agree with that. Now, even if they say to round this off, you don't want to round there. If you round at that point right now and then plug your answer in and then round again at the end, you could likely and very likely have rounding errors. You never want to round in the middle of the problem and then round again at the end. Okay? Bless you. So if we say 12 pi in here, I'm going to put it over 1 to make it a fraction, just like the 100 over 360 is a fraction. Okay? Now here's the tricky part. A lot of times, they're going to say leave your answer in terms of pi. So I'm going to show you how to reduce this to make sure that you know how to do that. What I would do first of all is, since both of these numbers end in 0, I would divide by 10 and cancel that 0 out. And then I would look over here and see a 12 and a 36, and I know that 12 goes into 36 3 times. So I'm going to divide both of these by 12. Okay? And now if I look across the top, I have a 10 and a pi and a 1. So what's 10 times 1 times pi? 10 pi. Then on the bottom I have a 3, because that's canceled, and a 1. 3 times 1 is 3. So this is in inches. And so my answer is 10 pi over 3. Now if they say to round, then I wouldn't mess with all that. I just plug it in my calculator the way it is. I let it do its magic, and I get the answer. It's going to be somewhere around 9 something, I would guess.
I got 10.4.
10.7?
10.4.
Oh, I'm sorry. I went the wrong way in my head. I was saying 3.14 and 3 are about the same number. And I was thinking in my head the bigger number was on the bottom, but 3.14 is on top. So you're right. It's certainly more than 10. All right? Good. So if they say to round, though, I would have done it back here when I had 100 over 360 times 12 pi. And I just plug that in my calculator. 100 over 360 times 12 times pi. I get the answer. It'd be the same. Okay? There really is no way to mess that up. Doesn't matter if you use a fraction key, if you just go out all one line, if you multiply first, then divide. In this problem, it's all multiply and divide, and there's only one divide. And so the calculator is going to do it right no matter how you enter it in. I should say it this way. The calculator is going to give you the right answer no matter how you enter it in, even if you entered it in wrong, unless you all of a sudden multiply by 360 instead of dividing. But, okay? All right. The last slide here. So make sure we understand what concentric circles are. Concentric circles are 2 more circles with the same center but different radii. So we see these in life all the time, don't we? I'll ask again since I wasn't recording. I said, Thomas, what in your world do you see concentric circles in? Do you have an answer for me? None? Okay. How about you, Sean? Not sure. You guys are making this harder than you need to. Yeah, Connor?
Eyes.
Eyes? Okay. You're thinking your pupil and what's the colored part called? Iris. Yeah, good. Olivia?
A target.
A target. Okay. Justin, you have another one, or was the target yours? Okay. I think there's something else that's pretty obvious that you throw things at. What's that?
Dartboard.
A dartboard. How about tires? Unless one was flat. Are there concentric circles on a tire? Yeah, usually, right? The rim, the outside of the tire, quite often inside there's another circle, the hubcap. Okay? Lots of different places we see concentric circles. And the key is that they all have the same center but different radii. All right? So you don't have to panic about trying to get all 20 of these done today in class and do them at home tonight. I will give you all of tomorrow. We're going to spend another day working on this. Some people struggle with finding arc length and the difference between arc length and arc measure. So we're going to spend a fair amount of time practicing this in class. So let's not waste time. If we finish tomorrow early and we don't have anything else to keep us occupied, then I can move on. But my expectation is that we'll need a couple days on this.